Good times. All right, so let's do a couple problems that are awesome. This one right here, problem number 4, we want to be able to find all the solutions to 3x cubed plus 10x squared minus 9x minus 4 equals 0. It turns out that this problem factors. As we first glance at it, it doesn't look like it factors, does it? Like, I don't see a factoring option there, Mr. Gens. Fortunately, we have this awesome thing called the rational roots theorem. Rational roots theorem says, let's look at the degree identified as 3. So we know we're going to have 3 solutions. And then I identify my P's and Q's so I know my choices. What are the P's? 1, 2, and 4. I look at the factors of the last number. After I look at factors of the last number, I look at factors of the, and I get 1 and 3. So the choices are each of the P's divided by each of the Q's. So 1 divided by 1 is 1. And 2 divided by 1 is 2. And 4 divided by 1 is 4. And I write it as plus or minus. It could either be the positives or the negatives. Then I switch to dividing by 3, and I get plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. Sweet. Now, somebody asked a question last hour. They're like, well, Mr. Gens, I'm confused because right now it's like he just wants to make guesses. Yeah. The difference is we used to guess numbers from negative infinity to infinity, which was a rather large set of numbers. Wouldn't you agree? Yeah, that's a large set of numbers. Now what we're asking you to do is reduce that entire set just down to 12 numbers. Which one would you like to choose? All right. We try 1, we plug it in, we get 3 plus 10 minus 9 minus 4 is 0. Sweet. 1 worked. If 1 worked, what's the binomial that divides evenly into this polynomial? X minus 1. Man, you guys are smart. You must have a really good teacher. Take the 1, drop it in. 3, 10, negative 9, negative 4. As Carson said, synthetic division is awesome. We drop the 3, and we multiply. Add, multiply. Add, multiply, add. So we have x minus 1 times 3x squared plus 13x plus 4. So remember from the outset we said, does this actually factor? Yeah, it does. There. That's a method of factoring using the rational roots theorem. Can we finish this off? We have x minus 1 times. How does that factor? Very good. So, lo and behold, we do have solutions to this polynomial. X is equal to 1, negative 1/3, and negative 4. Those are my 3 solutions. They are also options from the very beginning with my choices. 1, negative 1/3, negative 4. Good idea that I'm on the right path. Flip it over for our last example for today. What is different about this problem? Okay, it's longer. Degree of 4. So that means this is the first one we've had 4 solutions. Oh boy. Yeah, there's a lot, huh? Well, our Q's are just 1, right? So that means our choices will be plus or minus all the P's. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, and plus or minus 48. Oh boy. Now, remember, Mr. Gens is giving you this test with no calculator. So what do you think the chances are that he'll give you one where the solution is 48? Pretty slim, right? Can you imagine taking 48 to the 4th power? And I'm going to show you that you would actually never have to do that. You would never have to do that. If you guess 48, you would never have to actually take 48 to the fourth power. And I'll show you why here in a minute. But first of all, what number do you want to guess? Kind of try that 1. As you roll it in, you get 1 plus 7 plus 8 minus 28. And right now, then you see that 48, like, oh man, that ain't happening, is it? So maybe try -1. Notice if you try -1 that the even ones stay the same, right? So x to the fourth, -1 to the fourth is still 1. Then this would change to minus. This would be plus. This would be a plus. So, yeah, no, that doesn't work either, huh? So the ones are out. We'll try 2. What's 2 to the fourth? 16 plus 2 to the third is 8 times 7 is 56. 2 squared is 4 times 8 is 32. Right now you're not feeling very good, but then all of a sudden you tried -28 times 2 is -56. Ooh, and minus 48. Look at us go now. We got -48, which offsets with those two, and then 56 and -56. Those cancel. We're good, huh? Yeah. Do you remember how I said if you guessed 48 that you never need to take 48 to the fourth power? You didn't need to take 2 to the fourth power either. If you don't like trying numbers by plugging it in, just take the number and run it through synthetic division. If it works, what should be your remainder? Yeah. So if you're ever like, you know what, I don't actually want to try plugging in the number, then just go ahead and try running through synthetic. And that way you don't have to take it in fourth power. You just drop it, multiply, add, multiply, add, multiply, add, multiply, add. So since 2 worked, that means that x minus 2 is a factor, and I get this as a result. What's going to be the degree of my new equation? It's third degree. If it's third degree, I either have to factor it, which would x cubed plus 9x squared plus 26 plus 24, would that factor? It doesn't, does it? So then we have to use the rational roots theorem again. Before you freak out too much, just look at how fortunate we are as we fell across this. Look at how fortunate we are. Just look at the problem. It now ends in a 24, which means the 48s don't work, do they? Nor do the 16s. Since the ones didn't work before, they still don't work. And furthermore, what do you notice about all the coefficients? They are positive. And if they're all positive, what kind of numbers can I use? You can't use positives, can you? Because if you plug in a positive, you're just going to get another positive. You're going to have to try a negative. What's the first negative you like to try? I don't even want to write out the polynomial. So what I'm going to do is I'm just going to take that -2, and I'm going to try it through synthetic division. Because I'm on a roll, right? Like it's a test. I've only got a certain amount of time. This feels good. Drop it down. 1, multiply, -2. Add 7, multiply, -14. Add 12, multiply, -24, add 0. Cool. So I've got x minus 2 times x plus 2 times x squared plus 7x plus 12. So I factored that quartic. I factored it down to here, and we can see that the 7x plus 12 does factor. X minus 2, x plus 2, x plus 3, x plus 4. So x is what? Plus or minus 2, -3, -4. That didn't take that long. It took about, what, 3 minutes? If I asked you to graph it, could you? Now you're like, Mr. Gibbs, why are you doing this? The problem doesn't say graph it. Because it's just fun. Every once in a while, you got to stop and smell the roses and say, hey, why did I go through all this work? So I could look at the pretty picture it makes. Beauty is in the eye of the beholder, Hannah. Don't judge me. That's all I have for you. Unless you'd like me to fill up more of your work time with other stuff. Get to work, folks. Good luck on your Western test. Same as